All right, here we go for that final step, predicting the salary of the position level 6.5 with both linear regression and polynomial regression. So we're going to start with linear regression first, therefore creating a new code cell here. And so now, well, I asked you to figure out how to predict a single observation, the dependent variable for a single observation, meaning the position level 6.5. Well, let's do it step by step. Of course, the first step you had to do here was to take your linear regressor object, from the simple linear regression model, and this object was named linreg, this one. And then, very simply, from this object you're going to call the predict method to predict the salary of the position level 6.5. All right, so what exactly do you need to input here in this predict method to get such a predicted salary? Well, I'm sure some of you tried to directly input 6.5, but unfortunately this is not that simple, because indeed you always have to input your observations in an array, right? That's what is specified here in the parameters. The input of the predict method should be an array-like or a sparse matrix. So an array-like is, for example, a NumPy array or a simple array with double pair of square brackets. Well, I said it. That's exactly how you need to input an array, because generally in Python, an array is built with pairs of square brackets. If you add just a single pair of square brackets here, well, that actually creates a list, or you can also see it as a vector. But in order to create an array, well, an array contains several dimensions, like 2 dimensions in our case here, and therefore you need to add a double pair of square brackets. What does this double pair of square brackets mean? Well, the first pair of square brackets here corresponds to the first dimension, and the second pair of square brackets here corresponds to the second dimension. So the first dimension is actually corresponding to the rows in your array, and the second dimension is corresponding to your column. So for example, if I add, just to show you, if I add, for example, 5 here, that would create actually an array of 1 row and 2 columns. And if I add here a comma and then another pair of square brackets and then, for example, 2 and 3, well, this would create indeed an array of 2 rows and 2 columns. In the first row you would have 6.5 and 5, and in the second row you would have 2 and 3. So you see, the first square bracket here corresponds to the rows and the second one corresponds to the columns. All right, so let's go back to where we were, exactly this. So this indeed is exactly the format expected by this predict method, an array of 2 dimensions. Even if this only contains one cell, one value, well, it has to be in this format. And now, well, you're ready to get that prediction. So before we execute this, let's remember that this person asked for a 160K salary, and this is justified by the fact that this person earned a 160K salary in the previous company, which is what we have to check right now. And we're going to check that first with the linear regression model, which returns indeed a salary of $330,000 per year. So if we actually use this model to negotiate with that person, we would actually find it super weird, right? Because this predicted salary is way over the real salary that this person had in its previous company. So clearly, the prediction here is wrong, and that's what we can clearly see on the graph, the graph above showing the results of the linear regression model. 6.5 is somewhere around here, and indeed, if we want to get a prediction, we have to project it to that blue regression line, and then project it again to the vertical axis, which is around here, and indeed, that's what we get, this is multiplied by 10 to the power of 6, so indeed we get something around 330. All right, so anyway, that's a really bad prediction, so now we're going to get the good prediction, which we can clearly see here, that's 6.5, and we'll get a prediction around here, which will correspond indeed to the salary that this person mentioned. So let's do this, let's create a new code cell here, and to get that prediction, we're going to do it efficiently. I'm going to copy this and paste here. And now, once again, I would like you to press pause on this video and figure out what we have to replace here to indeed get the predicted salary resulting of our polynomial regression model. So please press pause, and then I'll tell you the solution right away. Okay, let's do this. Alright, so first the obvious thing you had to change is of course the name of your regressor, because for polynomial regression we named our regressor linreg2. And then exactly the same thing as before. Here we can't input that single position level, coming from the matrix of single feature, but instead, well, we have to exactly input, the features of this equation where x1 is equal to 6.5. And therefore what we need to input as features is this array composed of the following features values: 6.5 for x1, then 6.5 squared for x1 squared, then 6.5 at the power of 3 and 6.5 at the power of 4, because now we have built a polynomial regression model with degree 4. Alright, so here the exact thing that we have to predict, and we can actually input that efficiently by, taking exactly what we input here in the predict method, that polyreg object from which we call the fit transform method, to transform this matrix of single feature x into this matrix composed of the several features at the different powers. And here, well, of course, the feature value that we will input inside this fit transform method will not be x, but not 6.5 directly, like before, but once again, a 2D array containing the value of 6.5, the cell of 6.5. And so that's exactly the same as before. We need to enter this 6.5 value inside an array. Just before we had x here, x is an array, and now we have to input 6.5 in a 2D array, just like that. And now there you go, we're ready to get our predicted salary resulting from the polynomial regression model. So let's find out right away what is that predicted salary. And wonderful, the predicted salary is $159,000, which is super close to the salary mentioned by this person, as the previous salary earned in the previous company. So now we can be 100% confident to hire this person, because not only it is a good fit for the job, but also it is a very honest person. And we figured that out with polynomial regression. So congratulations, we all solved this case study. Not only we solved this case study, but you now know how to build a polynomial regression model, and you added that in your toolkit. This is your first nonlinear regression model. Congratulations for that. Now we're going to build 3 other ones, starting with the SVR, support vector for regression, and that's what we'll do in the next section. Now, for those of you who also want to study R, well, you'll find that same implementation, but in R, of course, in the next section. And for those of you who only want to learn Python, well, join me in the section after that to first learn about SVR with Kirill, and then implement the SVR model with me, which will be, by the way, on the same dataset with the same case study, so that we can actually compare the different results of our nonlinear regression models. So I can't wait to see you in these next sections, and until then, enjoy machine learning.